So many people have asked me to do differential equations. First, let's talk about a normal equation. It is y in terms of x, and as x changes, y will change. We can also add more complicated stuff, but this is still just a normal equation. We can make a table, give some x values, plug those x values into the equation, find out some decimal approximations, and then use those points to make a graph. So this is a differential equation. It's dy dx in terms of x and y. It's called a differential equation because dy dx is a differential. Differential is the instantaneous slope at that point. The reason we call it dy dx, slope is rise over run. And if we look at 2 points on a graph, the rise is the change in y values and the run is the change in x values. And since dyx is the instantaneous rate of change, we want to move our points closer together. And when they're moved right on top of each other, the 2 points are x1, y1. So we need to change this to a y1 and this to an x1. So what is the instantaneous slope? Imagine you're riding a roller coaster with a headlight on it. This is the direction the headlight would go. Now for this, if we subtract y1 minus y1 and x1 minus x1, we get 0 over 0. But we can tell right now this slope is not 0 over 0. It has a value. So instead of calling it 0 over 0, we call this y1 minus y1 dy and this x1 minus x1 dx. It's the difference in y and the difference in the x. So the dy dx is the instantaneous slope at that point. So how do we graph this? Can we make a traditional xy table? No, because if we plug in different values of x, we still have a dy dx here, so we're not able to solve for y. This isn't possible. The way we graph differential equations, we pick a point, in this case, -1, 1. We take our differential equation,